So in order to protect against attack and exploitation of vulnerabilities, we can implement controls. We can implement what's called defense in depth, where we have multiple layers of controls that implement security at each level. So, for example, in a physical sense, you may have a perimeter fence that's around the grounds of a company, and basically people can get in, and then you might have doors on the lock or access controls on locks of the building, and then further locks that on the offices that people work in, and then security on the computers, and it keeps going down. And so that's defense in depth. If one layer is breached for any reason, then there are multiple more to actually overcome before you've reached your target. And this is this idea of layering defense, somewhat like the layers or skin of an onion, where you're protecting the inside through all of these different layers that the attackers will have to get through. So traditionally, people implemented a perimeter firewall to protect a company, and this includes network firewalls that prevent certain types of traffic from getting into the network. This hasn't worked so well when everybody is working remotely. And so actually what we've seen, and we're not going to go into in a great deal of detail, but organizations are adopting what is called zero trust, where essentially the perimeter firewall is no longer seen as sufficient to keep people out of the internal environment. And no longer can you make the assumption that if somebody is internal, they're allowed to do certain things just by being in that network. It also doesn't work once somebody's breached that outer network, which if you make a whole bunch of assumptions, sort of about the security levels internally, then you can be severely disappointed once somebody's got in. Another approach is to partition networks into different functional concerns. So for example, here at the university, we might have administrative networks that are separate from student networks. Unify, the Wi-Fi network, is a separate network to the wired network that operates throughout the university, for example. But we can segment the network into further parts and then apply different rules based on where you are. Externally facing services like web servers can be put into what is called a demilitarized zone, which is essentially something that's protected by a firewall on the outside and a firewall on the inside that then allows the web server to get certain traffic from outside, but not to then access other protected assets internally. So this gives you an example of this. We have a network DMZ or DMZ, where a company employee internally is on an internal network and can access a website, and so can somebody on the public side of it, but the public is prevented from actually getting onto the internal network by this second firewall over here. So when it comes to protecting computers, we can establish a secure baseline image for a computer, which might be a configuration of Windows, for example, that has default user, system and security settings and certain software profiles. And that image will be used as the basis for all computers on a network. So once you've actually hardened a computer by protecting, removing unnecessary applications, making sure that it's all patched, etc., then you can then create that as a security baseline. You can alter that for certain individuals who might need access to particular applications, but every time you do so, you have to actually then see how that interacts with the baseline, but at least you've ensured that the baseline and the majority of the environment is secure. Another approach is to do something like implementing the Australian Signals Directorate Essential 8. and that involves 8 different types of controls. So, for example, application control, prevent the execution of unapproved malicious programs. That means limiting the access of applications, not running them as an administrator, for example, but also having software that will detect that it's doing unapproved things, so anti-malware, antivirus software. Targeting Microsoft Office in particular by disabling macros, so the ability for Microsoft Office applications to run code. And this is a common source of vulnerability in the Office products. It can be circumvented, of course, if you allow users to override those settings, and sometimes social attacks will convince the user that they need to do that to get access to particular information. Restricting administration privileges is also important. So even with administrators, they don't normally operate at that level of privilege all the time. When they want to carry out specific actions, they will be given access to do specific tasks. And you see this on Windows 10 when you want to try and run something and it requires administrative access. It will ask you, and then after you finish doing that action, it will then remove that access. Implementing multi-factor authentication, so authenticating users using SMS or some other type of multi-factor authentication. Doing daily backups of user drives and server information so that if you're hit by ransomware or a computer fails, then you're able to restore to a known state. Patching applications, updating them when they come out. Application hardening, which is going through a process with each application, removing unwanted components, removing administrative functions that you don't need, and various other factors, and then patching operating systems themselves. So a lot of applications of organizations don't even do the basics of this list. And so the ASD is now insisting through legislation that government organizations at least implement all 8 as part of their security practices. So application control is another set of vulnerabilities. Windows, for example, has a variety of scripting languages that can be used for malicious purposes. And those can be run from the command line applications like command.exe, PowerShell.exe, and applications like Microsoft Office, which runs VB script and JScript, a form of JavaScript. Although many of these attacks, as I've mentioned before, require a person to click on a link and allow a program or script to run, some of them don't actually need this. So some organizations will limit your access to command.exe and PowerShell.exe. If you buy a Microsoft laptop and it's running in Windows S mode, then you won't have access to command.exe, for example. They're working on the assumption that most normal users don't need it, and it provides a vulnerability by actually having that. There's a type of attack which is called living off the land, which is now increasingly common for attackers, where they use tools that are available on the computer rather than introducing their own custom-developed exploitation tools. So you're quite commonly seeing PowerShell commands, for example, being exploited by attackers to do malicious actions. Now, of course, this can be restricted to administrative privileges only, but of course there are ways of getting around that, including vulnerabilities that have been shown in PowerShell itself. Other controls are general users should be prevented from running scripts in PowerShell, and another scripting environment in Windows called Windows Script Host, WSH, and launching applications on Windows, anything with a file extension of .exe, and you can implement allow lists and block lists on applications to prevent anything that you haven't authorized from being run on a computer. I mentioned Microsoft Office macros. So Office has the ability to run these, which carry out automated functions that are useful in documents. So for example, doing a mail merge and then automatically inserting various bits of text into the mail is a type of office automation type application. And malicious users can craft macros that steal information or run malware, affecting confidentiality, integrity, and availability. So Microsoft has made it harder to run macros because you need to agree to running them before that running them. But that is not too hard, as I said. And so the approach to this is block the macros in Office and training users. And then to the right gives you an example of some type of Office macro type VB script that does something malicious, gets a username, for example, of a user. Restricting administration privileges is important. So a user with administration privileges can normally carry out all actions on a computer, including installing programs and device drivers, managing user accounts, and managing logging and auditing functions. This is why when attackers get access to a machine, they may initially do that with a user that doesn't have administrative privileges. They then go about a process which is called privilege escalation, where they try and get either more privileges in some way or get access to the administrator account, in which case they can carry out any action they want. If you do hacking challenges, then there's usually normally two parts to it. One is to gain access as a user, and then the second part is privilege escalation. So on Linux and Windows, there are special users, as I mentioned. On Linux, it's root, and on Windows, it's administrator. But any user can be given administrator privileges. And so it's not just these special accounts that have access to those privileges. So Windows will now make explicit when a user needs to use administrative privileges, so that gives you an extra warning, but of course you have to have somebody watching to be able to notice these things, and there are ways of circumventing that. So the vulnerability in this case is giving users administrator privileges when they don't need those privileges for everyday use. And attackers who get access to these accounts then have increased access thanks to those privileges. So to control that, we limit the number of users who have administrator rights, we train them how to use those rights, and we monitor those actions of anyone who uses those privileges. Sometimes you may have more than one person that needs to authorize actions to be able to carry out an administrative function, and that acts as a further control. We mentioned multi-factor authentication. So normal authentication uses a single factor, a password, often referred to as something you know authentication type. And we can further define factors as type 1, something you know, so a password, for example. Type 2, something you have, like a mobile phone, an authentication device of some sort, a key. Type 3, something you are or something you do. And so that's, again, related to your function, your work function. Somewhere you are, so geolocating a person or being on a particular network or on a device, mobile phone or laptop, and then having further type context-aware authentication, which allows you to do certain actions within a particular context, which could be time, location, on a particular machine, set of rules. So the vulnerability here is the attacker obtains a username and password and uses it to gain unauthorized access. And we've seen there are multiple ways of doing that through social attacks or getting access to usernames and passwords by having stolen credentials from systems or just bought them on the dark web. The controls are multi-factor authentication using multiple of these types. Now, obviously, it's not sensible just to use the same type multiple times. It makes more sense to use multiple different types. And then it's worth being aware that some second factors like SMS codes are relatively easy to get around. So having multi-factor authentication is good, but it can give us a false sense of security, and SMS codes are one example of that, where we really wouldn't trust them for safety critical issues, which is ironic given that the banks largely do. So using daily backups, this actually tries to address the vulnerability, which is that we lose access to files and information stored on disk because of disk failure, a lost device, or through ransomware or deletion. So to control against that vulnerability, we do daily backups, or we might back up to the cloud. Again, there's a whole process of how you do backups, whether they're incremental backups or snapshots, how often and how long you store that information for, and how frequently you do the backups. And a lot of that will depend on the nature of what you're trying to recover from, and what you're willing to actually lose if there was an event. So the other problem with this is the overhead of backups. You need storage, network use, the time it takes to restore from a backup, and then protecting the backup confidentiality, integrity, and availability. And we've seen with things like iPhones, for example, that you may assume that it's quite a secure device. You create an iCloud backup, and of course that is then vulnerable to access by not only criminals, but potentially law enforcement, nation states, other third parties. So patching applications and operating systems. A patch is a small update to an application and operating system software that usually fixes bugs rather than introduces major features, referred to as an upgrade. So the vulnerability in this context is software that can be exploited because there's a vulnerability in that version of the software. And the other vulnerability is that issuing a patch in and of itself tells the attackers that their vulnerability exists, and that there will be a class of people who haven't patched it who are vulnerable to that attack. So to control that, we update the application and the operating system with patches as soon as they're available. And patches are often complicated and can impact the availability of systems themselves. So we introduce a patch, and then we find that that patch then breaks some functionality that you were depending on, or some interaction with other applications. User fatigue in this context is one of the other problems, where we're constantly updating our systems, and so the companies are addressing that by doing things like automated updates overnight so that you don't notice it on devices like mobile phones, computers, for example, but when you're in an organization, it becomes a problem. Doing this on cloud infrastructure is slightly easier, and so architecting applications so that they can be updated dynamically is actually very important. So application hardening, which I've mentioned before, is where many applications come with features and default settings that are insecure. They may come with default passwords that are same for each product. And examples of that are in IoT devices, routers, server software, but even applications, especially open source ones that were installed, and they would have a default username and password, something like admin, for example, where you're expected to go in and set or change the password, but of course many people didn't, and so that's always why it's worth, if you're testing for vulnerabilities, checking that default passwords are not still set. So hardening the application involves removing default features and settings and setting new passwords. Anti-malware software, also known as antivirus, can be installed at endpoints, so on the computers, mobile devices or tablets, or on edge devices like routers. They work either in real time, so scanning network traffic and file changes, but they can also do disk scans. So that's where periodically they'll set off a scan and then scan for changes on the disk. But you also want to check for dynamic traffic, because Essentially, you can detect potential attacks before they've happened, or you can detect attacks that are happening whilst they're in progress. You can also look for anomalous traffic as well. So they work by looking for a range of indicators such as file signatures based on file hashes, presence of certain strings in the application, or looking at system functionality that is not normal for applications. So there's difference between static and dynamic behavior. More recently, anti-malware operates on behavioral analysis, so anomaly based, and looks for behavior that's typical of malware, looking for unexpected network traffic or attempts to change memory, for example, or access to other application. This is increasingly done using machine learning techniques, and of course, to combat that, malware is now looking at ways of subverting that, and we will look at that in one of the labs later on in this course. Software also does other things now that it looks like looking for suspicious browsing, blocking websites that have known malware sites, blocking spam, for example, so the level of sophistication of anti-malware and the products that are being offered is growing by the day. And as I mentioned, malware is trying to adapt and evade these things, including anomaly-based software, and even disable the anti-malware software. Malware will also try and evade from forensic examination by detecting whether it's running in constrained environments and then sort of shutting themselves down. So essentially it will only try and run when nobody's looking. An intrusion detection system is another type of control, and that can be network-based or host-based. So like anti-malware, it uses a knowledge-based and behavioral-based approaches to detection. Behavioral-based approaches take a baseline of network traffic and other factors and look for changes. And the knowledge base is looking for specific types of network traffic to create an event. So IDS systems report back to what's called a Security Information Event Manager, a SIEM, and that can alert security staff of any issues. IDSs may take some active measures such as blocking traffic on finding an anomaly, but that's usually the preserve of the thing that we're going to consider next, which is an intrusion protection system. So IPS, intrusion protection system, is usually placed inline in the network. So like IDSs, they use knowledge-based and behavioral-based approaches. An IPS will take active measures to block malicious activity, and they're sometimes combined with IDSs to create an IDPS. And an example of one is called Snort, which is an open source IPS system. Honeypots, we've seen one in the labs called Cowrie, and this is a system that is put on the network to lure attackers to attack it and not the real network. The honeypot is isolated from any other network, meaning that the attackers spend time trying to escape it. It can be sophisticated and replicate multiple machines, services, and users, sometimes referred to as honey nets. And it monitors attempts at probing, so looks for scans, for example. So you can put these honeypots on your network at various points. There's honeypots that might exist on the internet at large and provide central information back to a central source. So it gives us a geographical picture of where attacks are originating from. Data loss prevention, DLP, is a system that tries and prevents data from being exfiltrated or taken out of an organization. DLPs monitor for the amount of encrypted data being sent out of an organization, and that's often a giveaway that somebody is trying to exfiltrate. So rather than just sending out or copying files unencrypted, which can be detected by all sorts of devices, hackers or attackers will encrypt the data first before sending it out. And so one way of detecting that is to look for large volumes, and of course the attackers will try and circumvent that by sending it out in pieces over a period of time. DLP can also watermark documents, and that can include having beacons within a document that will alert the owners that if the document has been sent out of an organization, opened on a computer where it shouldn't be. DLPs will also monitor email from users and warn them if they're about to violate a policy by sending data outside. And that the effectiveness of DLP, and take this with a grain of salt, is that if you had used it, or if it had been used by Sony Pictures, they would have noticed that 25 gigabytes of emails were stolen from them when they were hacked back in 2014. So an attack that was attributed to the North Koreans at the time.